In the last video, we looked at these resistors here. So they're all multiples of 10, and each one is 10 times higher than the one below it. So 10 ohm, 100 ohm, 1000, 10,000, 100,000, 1 million, and 10 million ohms. And so they provide a predictable amount of current when you put a 5-volt power supply directly across them. We had the meter in series to measure the current in the last video, but the meter doesn't really affect the current at all. It just lets it run through it and measures it for the most part. So that was pretty straightforward, and we know we will have 5 in the number because all these start with 1. So 5 divided by 1, and then they have a certain number of zeros after them. So it's all just zeros, and so the rest of the number is 0. You'll have 5 with other zeros around it. In this video, we're going to complicate it by adding an LED, which provides voltage drop. So the resistor will still set the current, but the LED is going to affect the voltage across the resistor and thus the current that flows through the circuit. So now I added LEDs to the resistors. I put the long lead to the resistor, the short lead, the cathode, I put down one. So LEDs are a type of diode. They only conduct in one direction unless you raise the voltage enough to force it to conduct, well, what's called reverse bias, but that damages it. So you don't want to do that. You only want it to conduct while it's forward biased, and that's when the anode, the long lead here, is more positive than the cathode. So I added them. I'm not going to add one to the 100 ohm resistor or the 10 ohm resistor because they are limited to about 20 milliamps of current. And so we saw in the last video with a 100 ohm resistor you will have 50 milliamps of current, and the power is off. Let's turn the power on. In any case, we are going to complete the circuit again as we did in the last video to measure current, and that's pretty straightforward. Make sure the meter, the red probe, is where you measure milliamps. It does say milliamps there, and that the setting is at milliamps. And it's a good idea as soon as you're done measuring current to get it off of measuring milliamps, because if you try to measure voltage while you're measuring milliamps, a good chance unlimited current, for the most part, whatever the power supply can provide, will go through the meter and maybe blow a fuse, maybe damage the meter. So in any case, we're going to come to the 1 kilo ohm resistor, and we saw in the last video we could expect 5 milliamps of current. Now we have 3.11 milliamps of current because we have the resistor and the LED in series. So the resistor still set the voltage, but we have 5 volts at the rail, and now because it's a 1000 ohm resistor, we saw that we had 3.1 milliamps of current going through the 3 components. So the same amount of current is going through all 3 components. So that tells us that there is 3.1 milliamps of current across the resistor. And the reason why that is because the LED is actually blocking some voltage. So I'm going to use this jumper to get that resistor and LED passing current while we measure voltage. And so this is the first time I did this measurement, and as I just said, we can expect 3.1, it might vary a little bit, but 3.1 volts across the resistor. And there we go, just a spec below, 3.1. Now we're going to measure the voltage across the LED. Let's go over here, and what it's going to be is basically 2 volts. Right there, so 1.9. So it is less, a little less than 2 volts, but this is not exact numbers. So you can see there that some of the voltage now is across the LED. So as I said before, to conduct and light up, it has to be forward biased. It has a forward voltage. So it actually blocks up to about 2 volts, in that range. The more current that's flowing through it, the more voltage it blocks, but it's still around 2 volts. And it goes up to maybe 2.2 volts with a lot of current going across it, and down to 1.6, 1.5 volts with little current going. So this isn't a lot of current. Now we will, I didn't add an LED to this next one. So we'll go to the next one. That was the 1000 ohm resistor there. We're going to come down here and do the same thing. So we're going to measure milliamps of current right there and complete the circuit. So you'll see this LED down here light up, and there you can see we have basically that same number, 0.3 and a little bit more right there for the current. And that's because, again, we have 5 volts, but we have that voltage drop of the LED. There's a voltage buildup. Even though the current has gone down, the voltage is about the same. It's again, it went down, as we'll see, because there's less current, but not drastically, not the 10 times. We were using 10 times as much resistance, and the voltage drop of the LED changed a little bit. But we saw 3.3 milliamps of current because it's a 10 kilo ohm resistor, so we can expect about 3.3 volts across the resistor. And there you can see 3.2, and so it's slightly different. That's the thing with electronics. You don't have to be exact. You just have to get a general idea what's going on. So 3.2 versus 3.3 volts generally doesn't make a difference. There's other factors in play here that will kind of alter our numbers. But there you can see the rest of the voltage. Not as much now, as I said, because it's lower current and the LED is not as bright, as you can see, but it's blocking less voltage. So it is still blocking about the same voltage though. It is really close, even though we have 1/10 of the current going through there. So it does change a bit, but it's not real drastic, but it is something to be aware of. So let's we can even leave that plugged in right now. Let's go to the next one, and hopefully I made my point on the LED. So when you're looking at the current that the resistor will set, it's not just the power source voltage and the we're gonna have to go to microamp for this one. It's not just the power source voltage and the resistor, it's everything in series with it. And there we can see 33.5 microamps, and up here we had, it's 1/10 the resistance, so 10 times the current, other than some different voltage drops. There you can see. So it's still going the same. The LEDs, they block basically a certain voltage with a tiny variation, but still they drop that voltage from the resistor. That's the main takeaway. And that LED, I don't know why it's not lit up, but let's check the voltage across the resistor. Try not to short anything out. It's not a big risk. We definitely don't want to short the power supply though. But yeah, there you can see 3.3, almost 3.4 now volts across the resistor, and the LED again. So it's gotten down just a speck below the 1.6 volts. And let's turn the overhead light off and kind of put my hand there. Now you can see it glow. So it's just it's glowing. It's definitely glowing. A lot of LEDs I think will not glow, maybe at all, at this low of current, but these ones still do. And let's even see if we can get current through this last one. We might even, just for fun, see if we can see it glowing. Let's set the milliamps and get the probes back up. So that's amps. Actually, we need microamps. And so let's go with the 1 million ohm one, because with the 10 million ohm one we had like 0.3 microamp, and the same as like 300 nanoamps, and that's very, very small for this meter, and that was just with the resistor. So there you can see we still have that 3, and it's not surprising, it's a little bit higher now, 3.4. so that 3.4 But now that is in microamps, so very, very low amount of current. Let's see if we can even see any light. These LEDs do, I've had other LEDs that don't show near as much light. So yeah, there is current going through it, but not enough. Maybe if we made it dark enough, we would see a slight glow. But anyways, the thing is, voltage drops, they're pretty steady, and so they take the voltage off the resistors. So even though when you're learning Ohm's law, this is a problem I had learning Ohm's law anyways, they mention the voltage and the resistance. Voltage divided by resistance is current, and they left it there. So I didn't realize, you know, you put LEDs in there and other stuff, it actually takes voltage off of the resistors. And so ultimately, it's going to spread out the voltage across series components, not parallel components, but series components. Everything that is one in line with the other. So we had the power supply coming to a resistor, positive there, to an LED, and then through the meter. All of that was in series. All of that had the same current going through it. So the power supply had to split up the voltages, as we just saw, based on the current flowing through there. So as long as you know the value of the resistor, if you measure the voltage across it, that will give you the current. If there's another resistor in series, then it will have whatever voltage across it to also hold that current. Altogether, there'll be more resistors in series, so there'll be less current because there'll be more resistance. They'll add up, but they'll still split up the voltage as needed to have that amount of current flow through them. So that's all important stuff for every single circuit, but it's not terribly exciting. So thanks for sticking around this long, and hopefully when you look at more exciting circuits now, you'll understand them better because you understand this.